All right, guys. This is 4.5, our last unit of chapter 4. Okay, let me just move this cable around. So we are analyzing again using a few different steps here. So the title of 4.5 is the graph of a rational function. And for this particular example, use steps 1 to 7 to analyze each graph or each equation. Before we start, I know a lot of you have been reminding me about a joke. Okay, so here's our video joke of today. What did one egg say to the other egg? What did one egg say to the other egg? Let's get cracking! See, eggs, they crack, so let's get cracking, right? So, let's continue. Let's use steps 1 to 7 to analyze the graph. And if you're listening, I'm not going to have you memorize the steps at all. Okay, and I modified this a little bit from the book. So when you guys are doing your homework, please use these steps here. So step 1, factor the numerator and denominator of r. Find the domain of the rational function. So I'm going to try to be really, really neat. Okay, it's better if you write keywords out, so that way it stays in your mind, and then it helps you remember, oh, you know what, this is what I'm doing. Okay, the meaning of each step. So step 1, factor, okay, and domain. So factoring r of x equals, the denominator I can't really factor, but the numerator I could. It's going to be x plus 2 times x plus 1. So those are the factors. And it said also, in addition to factoring, I need to find the domain. Because the only term we have in the denominator is x, therefore the domain is x can never ever be 0. So that's our step 1. Step 2, write r in the lowest terms. So let's write step 2. Well, since we can't really reduce the lowest term, it's itself. So this is our step 2. Keep in mind that if it's reducible, we would be using this right here for the remaining steps, okay? Step 3, let's move up a little bit. Step 3, locate the intercepts of the graph. So this is telling me I need to find the x-intercepts, and also telling me I need to find the y-intercepts, okay? These, we're going to box our answers in here. Okay. X-intercept, meaning y has to be 0. Okay, so we're going to take our function here, whether it's reduced or not, but whatever this here is on step 2. So when y is 0, we're going to take that and set equals to 0. Then we have x plus 2 times x plus 1. That's our numerator all over our denominator, which is x. I'm going to get a red pen. How about that? I'm going to put this over 1 as well. You can solve for your x-intercepts 2 ways. You can cross multiply, okay, or you can multiply both sides by x. It doesn't really matter your method. It will always be the same. So I'm going to cross multiply. So 0 times x, it's still 0, equals 2. Then this side times that. Okay, well, 1 times anything, it's itself. So I'm going to have x plus 2 times x plus 1. Well, check this out. Check this out, okay? What happened to my denominator? When I cross multiply, remember, when I'm looking for x-intercept, y has to be 0. So when you cross multiply, the denominator disappears. And that will always, always be the case, okay? So if I were you, and if you are listening, I would totally write that out. X-intercept is the same as taking the denominator and setting it equal to 0. All right? So again, if you are listening, you should write this out so you will know for yourself. I'm not going to spell this out for you because when I stamp your notes, this is what I'm going to look for. X-intercept is the same as taking the denominator, sorry, not the denominator, the numerator, and setting it equals to 0. So this is what I ended up with after I cross multiply. Well, this is exactly the same as my numerator. So now it's already in factor form because of my first step. I'm just going to take each factor and I'm going to set it equals to 0. So x equals to -2, and over here x equals to -1. So I have two x-intercepts, okay? -2 comma 0 and -1 comma 0. Y-intercept is when x is 0. Okay, so let's look at this really quickly. Well, when x is 0, and by the way, you can use this or you can use this. It doesn't really matter if they are not reducible. Okay, because in theory, they are exactly the same if it's not reducible. When x is 0, so again, we're looking for y-intercept when x is 0. Well, I have a problem. We said originally x can never ever be 0. So this one, y-intercept, there is none. Okay? That means my curve would never ever ever touch or intersect or cross over the y-axis. Okay. We are now on step 4. It says locate the vertical asymptote, which is VA. Vertical asymptote, which is relating to our domain. Okay, so take your denominator, x equals to 0. That is my vertical asymptote. Step number 5, locate the horizontal or oblique. Okay, we need to determine that first. Then, this is the new piece that I need you guys to be very aware of. Determine points, if any, at which the graph of R intersects these asymptotes. Okay, so let's determine whether we have an RA, I'm sorry, not RA, HA or OA. So this is step 5. Well, the degree on the numerator is 2. Okay, so the degree R of x, numerator has a degree of 2, denominator has a degree of 1. Therefore, this is an improper. Okay, if it's an improper, we are going to end up with an oblique. Okay, and with an oblique, it's a y equals. I'm going to write a box here and I'm going to come back and fill in my answer. Because it is an oblique, we can do long division. Okay, this goes out here. Inside, it's already in descending order. So that means I don't have to rewrite it. There are no missing terms, so we are going to copy everything else down. So x squared divided by x is x. X times x is a positive x, but I need to subtract, so it is now negative x. Those two subtract to get a 0. Bring down your next term. 3x divided by x is simply 3. 3 times x is going to be positive 3x. I need to subtract, therefore we get a 0. Bring down your positive 2. Well, positive 2 can never divide by x because it doesn't have any x variable with it. So this is pretty much a remainder. Okay. Well, normally we write our remainder like this, right? X plus 3 plus 2 over our divisor, which is x. This is our quotient, which is the answer to a division problem. But in our oblique, remember, when x gets really, really big, the remainder is going to be not as significant. So we only take this piece right here. So our oblique is going to be x plus 3. Okay. So now the next piece is determine points, if any, at which the graph of R intersects these asymptotes. Well, we only have one, which is oblique. So now the next question is intersect OA? Question mark. Okay, we have to find it. And how we find it is this. This is a y equals. Well, this is also a y equal. Because they're both y equal, we can substitute one for another. So I'm going to take out this y and replace it with an x plus 3 equals to x squared plus 3x plus 2 all over my denominator, which is x. Okay. And again, if this was reducible, you would be using this right here. But because it wasn't reducible, doesn't matter which one. So again, let's talk about how we did this piece. This is a y equals. this is also y equals. If you have two y equals, you can set them equal to each other because in theory they are equal. Okay, so we're going to multiply this by making this into a fraction and cross multiply. Okay, so we are going to have x times x plus 3, that piece. Then we're going to do this as well. Okay, over here x to the second plus 3x plus 2 times 1 is going to be itself, because anything multiplied by 1 is itself. So x squared plus 3x plus 2, that's what I currently have. I'm going to distribute now. So this is going to be x squared plus 3x equals to this side, x squared plus 3x plus 2. Okay, you have an equation which has an x squared on the right and x squared on the left. So we can cancel because it's an equation. It's still going to be equal, which is balance. You also have a 3x over here and a 3x over here. Again, it's an equation, so you can cancel. Because you cancel everything out, you have 0 over here on the left and 2 over here on the right. Is it now equal? No, this doesn't work. Okay? Because it doesn't work and because it's not equal, well, how should we answer this piece? It does not intersect ROA. Okay, so how we answer that is that R of x does not intersect. Sorry, my red pen is kind of dying. Let me get a different one. Intersect. So R of x does not intersect our oblique asymptote. And yes, you box that up because that's part of step 5. Okay. Now we are moving on to step 6, graph R using a graphing utility. Okay. Now if I were you, I would pause this right now and try it out with your calculator. Here's my old school one. I'm going to put in this. Oh, by the way, this is the same, so you can enter in whatever you wish. Parentheses x squared plus 3x plus 2, close it, divided by x. Let's change my window from standard form first, and then we can go from there. Okay, graph. There's one piece and there's another piece. Notice how using the calculator it's quite confusing. Okay, so if I were you, I wouldn't even use it at all. Okay, I'm going to, this step doesn't help me. Okay, so what I'm going to do is I'm going to change this out. And remember in our previous set of notes, let me go back and find the one with the 7 or 8 steps as well. We went and changed a step so that way it's more clear or clearer when we're graphing it by hand. I just have to find this. Here we go. Okay. This is right here. Remember this? It said using a graphing utility, and then I kind of cross it out and and then I change it to a number line. And that's exactly what I'm going to do. Because look at this. It's quite confusing. How do you know where the horizontal asymptote is, the vertical asymptote is, or an oblique asymptote is? There's no way, right? So on step 6, here we go. On step 6, I'm going to cross it out and do not use a graphing utility. You can create a number line to find points. Okay. To find points around each x-intercept. Okay. So it's word for word of that, okay? So we cross out the graphing utility, create a number line to find points on the graph around each x-intercept. No calculator. So that's exactly what I'm going to do. So I'm going to do right over here, step 6. Step 6, here's our number line. Okay. We have a number line. We need to go back and find our 2 x-intercepts. One of it was at -2 and one of it was at -1. Okay. Moreover, I'm also going to ask you to put in your VA. So the VA goes right over here. The reason is that the VA, it's also an X. Okay, so the VA is also X. So these are all crossing or touching the X-axis. Okay, so let's add that to here. Create a number line to find points around each X-intercept and VA. Okay, that's important. All right. So we have 3 things, 2 X-intercept and 1 VA. We plot it all here in order. So we're going to pick a value over here on the left-hand side, such as f of a negative 100. It's a really large negative number. So let's look. Negative 100 plus 2. Okay, that's going to be a negative. Negative 100 plus 1. That's negative. Divided by negative 100, which is negative. Negative times a negative is a positive. Positive divided by negative is a negative. Easy, right? So between negative 1 and negative 2, I don't really have a lot of choices. So I'm just going to put negative 1/2. Okay. Negative 1/2 plus 2, that's positive. Negative 1/2 plus 1, that's negative. Divided by negative 1/2, which is a negative. Positive times a negative is a negative. A negative divided by negative is a positive. Okay. In between negative 1 and 0, I don't have a lot of choices, so I'm going to pick negative 0.5. Okay. Negative 0.5 plus 2, that is positive. Negative 0.5 plus 1, that's also positive. Negative 0.5 on the denominator, so that's a negative. Positive divided by negative, I do have negative, so this is now negative. We now have one last piece of info. Okay. We are now going to put in f of a really large number because I don't have anything else over here that I need to test on the way to 0. So 100 plus 2, that's positive. 100 plus 1, that's also positive. Divided by 100, which is also positive. So this is all positive. So everything on this side is all positive. Okay. Now let's look back. Okay. It's telling me that in between negative 2 and negative 1, there's some sort of a positive y here. But is that very clear on the calculator, the graphing calculator? Not really. So that's why sometimes relying on a calculator is a bad idea, right? So we are not going to use a calculator at all. Notice this process. We're just kind of using it to check the work to make sure that it's sort of lining up. But in reality, doing things by hand, using your brain, it's so much better. All right. Since I'm kind of running out of space, I'm just going to graph it right here. Let me get a... Okay, this is step 7. Oh, how about this? Can we fit it all on this top? Let's do it here, okay? So, step 7. We have not too large of an x. Okay, not too large of an x-axis. So, x-axis, I don't need to go very far. Y-axis, we have an oblique here. So, okay, let's start. First step, it says factor in the domain, so I can't really plot any of that on my graph. Let me zoom out really quick. There it is. Okay, so we have the whole thing here with this. Okay. Step 2, we reduce. It wasn't reducible, so we can't use anything there. Step 3, yes, we can definitely plot in our x and y-intercept. Okay, so x-intercept is one of its -2, -1, -2. Another one is -1. Okay, neatly and clearly plot those in. Then y-intercept is none. We are done with step 3, looks like. Step 4, we have a vertical asymptote at 0. So let's use a different color marker or pen. So x is at 0, which is this right here. Label that for me, please. Yes, I want you to label everything. X equals to 0. That is our step 4. Step 5, we were supposed to be looking for either HA or OA, and we found an OA. So OA is y equals x plus 3. That means a y-intercept at 3. So put in tick marks. So when y is 3, 1, 2, 3, make a dot. 1, 2, 3. And by the way, I found this pencil. So if this is yours, you can come and claim it. So when y is 3, then the slope is 1, so 1 over 1. So go up 1 over 1, go up 1 over 1, go up 1 over. I want to make sure I'm doing this right. Go down 1, left 1, down 1, left 1, down 1, left 1. Okay. So that's a lot of points, which is good. So I can get a better asymptote. Okay. So here is what I'm supposed to have. Extend it far out. Okay. So these are just 2 x-intercepts, 1 OA, 1 VA. Then that's our step 5. Now step 6, remember, if we don't have a calculator, now the calculator did an okay job. It didn't do a great job. I can't see anything here, and I don't know exactly where the OA is, and it doesn't show your VA. So using a calculator alone is not going to be very useful. But here's the deal. Notice how, according to your step 6, on the left-hand side of -2, see that right there? It tells me that my y value should be negative. So here's -2. It tells me that, hey, I should not be above it, I should be below it. And remember, when we test it out, it doesn't intersect my OA, so I can't touch my OA at all. So I know that it's supposed to be negative over here. And according to our asymptote definition, the curves will always be hugging or approach all asymptotes. So that's why it should always be very close. Now, in between -2 and -1, it tells me that my y value is positive, which the calculator isn't very clear. But because I have step 6, I am now smarter than my calculator, and I know I'm supposed to be above it. See that right there? Oh, that tricky piece, right? Let me zoom in. Whoop. Here we go. All right. So now I know that in between -2 and -1, according to my steps number 6, it said, hey, silly girl, you're supposed to have a positive y. So that's why I know to go above the x-axis. Okay. Then, in between -1 and 0, my step 6 says, hey, you're supposed to have a -y. So I know I'm not supposed to be looping back up, so I need to go straight down. Okay, and this is supposed to be smooth and continuous, okay, and be approaching all asymptotes. So with just a sketch, this is what I'm supposed to have. Now, you have 1 VA, meaning that you should have 2 curves, one on the left and one on the right. Well, on the right, you have a couple of options, okay? You can have it here, or you can have it here. So let's talk about what would it be like. Don't sketch this out. What would it be like for you to have this, okay? Remember, you can only have 2 curves. You can't have 3. So you have one on the left and one on the right. On the right, you have a choice, either on the top or on the bottom. So let's say, hey, what if I do pick the bottom? Then I need to look back at my step 6 and say, well, on the right-hand side of 0, okay, my number line says all of my y values should be positive. Okay, so look at this. All of my y values should be positive. If this is the piece that I pick, it kind of contradicts, okay, step 6. So I can't have this because look, this right here is a negative y value. So the only other piece I can have is that very top piece, okay? And that top piece said, hey, you know what? It does match up with step 6 because it says whatever I pick over here on the left-hand side of 0, it's always positive. So as you can see right there, that is my awesome looking curve. Okay. Okay. So this is pretty much the end of this example, and I'm trying to zoom it out so you can have a complete page of notes here. Okay, and at any point that this is going too fast for you, please just hit pause, rewind it, and then listen to it again. And this is the end of our notes. Have a wonderful day.